Right, onto variation. We're going to do direct variation and inverse variation. Here's direct variation. Okay, now supposing in 1 hour you earn $35. 2 hours, you earn $70. Okay, you're earning $35 an hour. Okay, so basically your earnings are varying directly with time. Okay, again, the more hours you work, the more pay you get, but it does vary directly. It's like a constant. Okay, it's like a linear function is this. Now if we look down here, okay, so this is direct variation. So we can actually write it as this actual equation here. Your earnings vary directly with time. Okay, $35 an hour. Again, 2 hours you're going to $70. 3 hours, $105. Okay, so this is your equation, and actually here's the general form: y equals k of x. I'm going to write that. Okay, this is direct variation. Y equals k of x. In other words, y varies directly with x. Okay, remember that y varies directly with x. Here it is. Okay, let's do some examples. Okay, let's have a look up here. Right, find the variation constant. Y varies directly as x, so I'm going to use this equation. Now y is 32, x is 2. Can you see that k equals 16? It's as straightforward as that. Okay, so it's like saying you earn $32 in 2 hours, so you're earning $16 per hour. Okay, now let's look at some more examples. Right, you've got to be careful. Number of centimeters W of water varies directly with S. You could say W equals KS. Okay, W varies directly with S. I know they've got it written like this. Okay, now let's have a look. 100 centimeters of snow will melt to 16.8. So water, 16.8. Don't know what the variation constant is, but the snow is 150. Divide both sides by the number next to the letter, you're going to get this here. There you go. That's the variation constant. Now, part 2 of the question is going to be this. Okay, let's have a look. What will 200 centimeters of snow melt to? Okay, well now we've got this. Now we know that K is 0.112. This time it's 200 centimeters of snow. Okay, I can find out what the water is. Okay, and it should be down here. There we go. Okay, 22.4. Okay, so I found what K was and I used it. Let's keep on going. Now how about inverse variation? Okay, instead of y equals kx, we're going to have y equals k over x. Here it is. It's inversely proportional. Okay, up here. So, but you're choosing the same thing again. Look, if y is 16, let's have a look. Y put 16 here. X is 0.3. This time multiply by 0.3. Okay, you're going to get k equals 4.8. And again, if I had to use that in part 2 of the question, I know that k equals 4.8. Let's have a look at some more complicated ones. So remember, could be all sorts of kind of problems, inversely depending on squares or something like that. It could be different. Let's have a look at some examples. Equation of variation, right? Y varies directly. So y equals, if it's directly, k, it's not going to be the denominator, that's inverse. Right, directly as the square of x. Okay, not inversely. If it was, I would have put the x squared on the bottom. This is directly. There's my equation. There it is. Okay, again, just using the numbers. If y is 12 and x is 2, so that becomes 4. Divide by the 4, k is 3. Okay, there you go. That is you just using y varies directly as the square of x, but you have to create your little equation. More. Equation y varies jointly as x and z, and inversely as the square of w. So basically you can count this directly. Y varies directly with x, so again y. It's always y equals k. Y equals k. Right, if it's directly, put it next to it, x and z. If it's inversely, I'm going to put it on the bottom, w squared. Okay, is that right? And that's what I have there. Okay, so look at this. Let's get the arrow. Okay, look at that. So look at this again. Y varies jointly. Think of it directly with x. Okay, so next to it and z, next to it inversely square of w as a denominator. Okay, and again you just put in the numbers in there and you're going to find out what k equals. Okay, and you can create a little equation there as well. Okay, so there you go.